We are now ready to start Unit 2 of Pre-Calculus A. And the whole theme with this unit is going to be a lot of stuff on the XY axis in the coordinate plane. Okay, everything from today rectangular coordinates to tomorrow distance and midpoint to some graphing and so forth. Some very basic graphs. So let's dig in. So here's some definitions we're going to be going over today. Okay, first of all, the rectangular coordinate system, it's going to be taking these number lines that we did back in the last unit, and we're going to have that horizontal number line. So we're just going to name it the x-axis. Okay, and we're going to put another number line on top of it and call it the y-axis. And we're interested in what's going on this x-axis, around the y-axis, and all the two-dimensional shapes, two-dimensional areas going around these axes. So I've got a better one drawn here. So let's go through and just kind of label some stuff you saw on that last slide. Okay, for instance, we have our x-axis and y-axis. It'll be a little bit darker running through the middle of your paper. Okay, so right here where the axes cross, this is known as the origin. Okay, the origin. So what's going to happen is we're going to be given a point, or we're going to have to find a point. And what we're going to do to get to that point is we're going to see how far we had to go on the x-axis and how far we had to go on the y-axis to get to that point. And so whatever that distance is, that's going to give me something called an ordered pair, where my x, my horizontal distance, comes first, and my vertical distance, y, comes second. And you can see there's a lot of room up here, so we actually name the four sections that this graph is divided into. So this one in the upper right-hand corner, that is called quadrant 1. This is quadrant 2. Down here we have quadrant 3. Over here, quadrant 4. Okay. Hopefully this is a review for you. So we're going to go ahead and jump into the first example. And it wants me to plot these ordered pairs and determine which quadrant they lie in. Okay. So I'm just going to start with A right there. It says 7. Remember, my x's all come first, and then my y's. So that means I need to go 7 on the x-axis. 1, 2, 3, 4, 5, 6, 7. And then up 5. 1, 2, 3, 4, 5. I landed right here. I went 7 in the x direction. Went a little farther. And then I went 5 in the y direction. And so instead of putting that whole point there, I've got this one labeled as A. I can just put a little A right there. Now let's see what happens on part B when we have some negatives. Okay, when we see negatives, we need to think of negative directions. Well, in the XY coordinate, a negative direction is either going to be going left and or going down. So for instance, my x is -4 this time. So that means I'm going to go to the left, 1, 2, 3, 4. Okay, I land right here at -4. And then I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I land right here at -9. So where these two would meet down here, if I was to keep going, where they would cross is right here. And we just call this point B. I'll let you guys go through and label. Oh, I'm sorry, we're supposed to go ahead and do quadrants on this. So this landed in quadrant 1. And we use Roman numerals for this. And then B right here landed in quadrant, oops, that was quadrant 3. Go ahead and pause the video and plot these last four, and we'll see if we get the same answers. Got a little tricky on some of them. I put them on the axis. So if it's on the axis, it's not actually in a quadrant. So I will just denote that by just putting what axis it is on. So F would have been on the x-axis, and C landed on the y-axis. So an application of actually plotting points gets us into statistics. It's something called a line graph. It's also known as a time series graph. And so what we're going to do is we're going to make our x's and y's, those different coordinates, actually mean something. A lot of times on a line graph or a time series graph, the X will stand for time, as it does here. As you can see, time down here, it says is years since 1970. So the 0 would actually represent 1970, and the 5, 1975, and then the 10, 1980, and so forth. Okay? And so the y-axis, or the y-axis, or the y-coordinates, I guess, that represents how many math and statistics degrees were given out in that year. Okay? Now these are in thousands, so my answers need to reflect that on these examples. Okay? So part A asks how many mathematics and statistics bachelor's degrees were awarded in 1995. So first thing I need to think about was 1995. How many years after 1970 was that? Well, that would be my 25th year. Ooh, let's not use green anymore. That says t equals 25. So I come to t equals 25 right here. And it says how many degrees were awarded. I'm just going to make my way up right here until I get to, oh, looks like it's between 13 and 14. This is so small. Might be a little bit higher than that. 13,500, 13,600, somewhere around there. I'm not going to be real picky about it since we're having to kind of estimate with this anyways. And of course, it wasn't exactly 13,600. They're having to put their point on there as well. Okay. So let's try it the other way. This time, it's asking in which years were the number of mathematics and statistics degrees awarded at the low of 11,000. So this time I'm wanting to look at my axis on this side, the 11,000. Okay, and I see that I hit this 11,000 mark twice in the 10 and the 30. Remember, those mean years after 1970. So 10 years after 1970 would have been 1980. And then 30 years after 1970 is the year 2000. Math and statistics, definitely a rewarding degree to get. I highly encourage it, just so you know. I'm definitely on the uptick over here. All right, I got my first degree right here, 34 years after 1970, and then my second math degree, I got 36 years after. So I'm where it's cool again. All right, I'm not in the downward spiral here where it's not cool. Here is a link to your homework. It's also in Google Classroom, and we are doing 2 to 42 even.